Hi class, in this video I'm going to talk about dividing polynomials when there are multiple terms involved in either the numerator or the denominator. But in these examples, there are going to be multiple terms involved in the denominator. So to solve for a question such as 4n plus 8 divided by 2, I'm just going to write an example on the board here that I want you to consider. So recall that if I had 2 over 7 plus 3 over 7, because the denominator is the same, I keep it the same when I add fractions, and I just add the numerator. So I'm going to end up having, for 2 over 7 plus 3 over 7, 2 plus 3 over 7. Now, we can apply that same logic to this question, but instead of putting it together, we can break it apart. So notice how I can break apart 2 plus 3 divided by 7 into 2 over 7 plus 3 over 7. So the same logic applies here. I can break down this question, 4n plus 8 divided by 2, as 4n divided by 2 plus 8 divided by 2. So now we just solve for these individually. So for 4n divided by 2, since 4 divided by 2 is going to be 2, I'm going to have 2n. I leave n alone because I don't have any other n's on the denominator to cancel out with it. Now I'm going to write plus 8 divided by 2. 8 divided by 2 is 4. So when I simplify this polynomial here, I'm going to have 2n plus 4. Okay, now for this question, the same logic would apply. I'm going to break this apart. So I'm going to have 16x squared divided by negative 4. Now I'm going to have negative 12x divided by negative 4. And I'm going to have 8 divided by negative 4. So 16 divided by negative 4 is going to be negative 4. And I don't have anything to cancel out x squared with, so I'm going to just have negative 4 times x squared. Now for my negative 12x divided by negative 4, since I have two negatives and I'm dividing them, my answer becomes a positive. So negative 12 divided by negative 4 is going to be positive 3. And I'm just going to write x here as 3x because there's nothing on the denominator that I can cancel my x with. And now 8 divided by negative 4 is going to be negative 2. So this would be my final answer. To make this a bit more simple, instead of plus negative 2, I'm just going to rewrite this as negative 4x squared plus 3x minus 2. So because plus negative 2 is the same as minus 2, I'm just going to write minus 2 instead, so it looks much more simple. Now, for our last example here, I'm going to have 3x squared plus 6x divided by 2. Now, if I can simplify the top, I would. However, I can't simplify the top any further, so I'm going to go ahead and break this apart as 3x squared divided by 2x plus 6x divided by 2x. Now, 3 divided by 2, I can't simplify anymore, so I'm going to leave it. However, x to the exponent of 2 divided by x to the exponent of 1, I can simplify. So recall there are invisible ones as exponents for variables that don't look like they have an exponent. So in this case, I'm going to have x to the exponent of 2 minus 1, because when I have the same base and I'm dividing, I can subtract the exponents. And then I'm going to have 6 divided by 2 is just going to be 3. And then I have x to the exponent of 1 minus 1. So in this case here, x to the exponent of 2 minus 1 will be x to the exponent of 1. So I'm going to have 3 times x to the exponent of 1 divided by 2. Now I'm going to have 3 times x to the exponent of 0. Now recall that instead of writing x to the exponent of 1, I can just write this as x because it's implied that there's an invisible 1 in front of any variable that doesn't have an exponent. So I'll just write this as 3x instead of 3x to the exponent of 1. That's still going to be divided by 2. for any number except for 0. So any number that has the exponent of 0 would equal to 1. So this would be 3 times 1. And to simplify this further, 3 times 1 is just 3. So my final answer would be 3x over 2 plus 3.